Lesson 10. Horizontal and vertical translations of functions. In this lesson you will learn about vertical and horizontal translations of functions. So in this lesson we'll be learning about vertical and horizontal translations of functions. A translation is the transformation, and a transformation is any change of a figure without changing its shape or orientation. So a translation is the transformation of a figure without changing its shape or orientation, and a transformation is any change. This means we can only slide the function around without changing the way it looks. So in a translation, we can only slide the function without changing its appearance. A function can be translated horizontally, right or left, vertically, up or down, or both horizontally and vertically. So we can translate a function horizontally, right or left, vertically, up or down, or both horizontally and vertically. To denote a vertical translation of a function, we must change the way a function is written. So if we want to denote a vertical translation of a function, we have to change the way a function is written. F of x plus c means that a function is translated upwards c units, and f of x minus c is used to denote a function which is translated down c units. So f of x plus c means a function is translated up c units, and f of x minus c means a function is translated down c units. We use the variable c to denote a vertical translation of a function. So the variable c denotes a vertical translation of a function. Let us look at an example. Suppose we are given the equation g of x equals f of x plus 3 and asked how many units the original function f of x equals x squared was translated. Since the value of c equals 3, so c is positive and the graph is translated up, the function g of x is simply the function f of x translated up 3 units, and the new equation for g of x is y equals x squared plus 3. So in this graph, we can see that the red function is g of x, and the blue function is f of x. And the function g of x is simply the function f of x translated 3 units up, and the new equation for g of x is y equals x squared plus 3. So the red parabola is the translated function g of x. The blue parabola is the original function f of x. So this is g of x, this is f of x. To denote a horizontal translation of a function, we must change the way a function is written. So if we want to denote a horizontal translation, we have to change the way a function is written. F of x minus d means that a function is translated to the right d units, and f of x plus d is used to denote a function which is translated to the left d units. So f of x minus d means the function is translated right d units, and f of x plus d means that a function is translated left d units. We use the variable d to denote a horizontal translation of a function, and our graph is translated horizontally d units. So the variable d denotes a horizontal translation of a function, and our graph is translated horizontally d units. Notice that since the standard written form for a horizontal translation Notice that since the standard written form for a horizontal translation is f of x minus d, you will have to change the sign in front of the d to determine the value of d. So because the standard form for a horizontal translation is f of x minus d, you have to change the sign in front of the d to determine the value of d. That's because this is a negative in front of the d. So you have to change the sign in front of the d to determine the value of d. I will show you what I mean in a moment. This is because f of x minus d equals f of x minus positive d, and f of x plus d equals f of x minus negative d. So we have to change the sign in front of the d to determine the value of d. So in this case, we had to change the sign from front of the d from negative, which as it appeared here, we had to space it out and add a positive. So f of x minus d is equal to f of x minus positive d, and the function is translated to the right d units. Here, f of x plus d, that didn't tell the whole story, because the standard form for the horizontal translation of a function is f of x minus d. So we had to transform it from this form to this form. And we have to do that by letting f of x be, by allowing f of x plus d to be equal to f of x minus negative d. So that means d is negative, and the function is translated left d units. Here d is positive, and the function is translated right d units. So f of x minus d is equal to f of x minus positive d, and f of x minus d is a case where the function is translated to the right d units. And here f of x plus d equals f of x minus negative d. And in this case, f of x plus d is equal to the function being translated to the left d units, because we have negative d, where we have f of x minus d in this form. F of x minus d is a standard form. So here f of x minus negative d is equal to f of x plus d. So d is equal, here d is equal to negative d, and we translate to the left d units. Let us look at an example. Suppose we are given the equation g of x equals f of x minus 3 and asked how many units the original function f of x equals x squared was translated, and in what direction. Since the value of d equals 3, so d is positive, and the graph is translated to the right, the function g of x is simply the function f of x translated 3 units to the right. How do we know that the value of d is 3? That's because we are told that here f of x minus 3. This is what we are given. And when we simplify, when we expand this, we have f of x plus negative 3. Sorry, f of x minus positive 3. So d is positive, and the graph is translated to the right, because we have a value of d that is equal to 3. So the function g of x is simply the function f of x translated 3 units to the right. Therefore g of x equals this function, f of x equals x squared, 3 units translated to the right. Or g of x equals x minus 3 squared. The red parabola is the translated function g of x. The blue parabola is the original function f of x. So the blue parabola is f of x equals x squared. The red parabola is g of x equals x minus 3 squared, which is simply the blue parabola, f of x equals x squared, translated 3 units to the right, to get us to g of x equals x minus 3 squared. Now that you know how each variable translates a function, you will be able to look at a function and describe any transformation on the base function. So now that we know how each variable translates a function, you can look at any function and describe any transformation on the base function. A base function is a function with no transformations applied, such as y equals x squared. So remember, a base function is a function where no transformations are applied. You will be able to state the domain and range of a function that is being transformed. So we will also be able to state the domain and range of functions that have been transformed. Let's look at an example. For the function g of x equals x plus 5 squared plus 1, describe any transformations from the base function f of x equals x squared. Also state the domain and range of the transformed function. For the function g of x equals x plus 5 squared plus 1, d equals negative 5. How do we know d equals negative 5? Because if we take x minus this number, it gives us x minus if we take x minus this number, it gives us x minus negative 5 is equal to x plus 5. So d is equal to negative 5. And c is equal to 1 because we simply have positive 1 tacked onto there. So the base function is translated 5 units left and 1 unit up, because d is negative 5 and c is equal to 1. Again, d is equal to negative 5 because if we expand this, we have x minus negative 5. And c is 1 because we only have the 1 tacked on. The domain does not change from the base function because any value of x can be entered into the function. So the domain does not change because any value of x can be entered into this function. Just like any value of x can be entered into this function, which was transformed from this function. Therefore, the domain is x belongs to the set of real numbers. Since the parabola moved up 1 unit, the range is now all real numbers that are greater than or equal to 1. So that's because the range for this function, f of x equals x squared, was all real numbers greater than or equal to 0. So if we shift 1 up, naturally, the range becomes all numbers greater than or equal to 1. Note that the value of d does not affect the domain or range, but the value of c directly affects the range. So d, moving it right or left, does not affect the domain or range. Obviously, that's because it doesn't affect the domain because it can still be any set of real numbers. The domain can still consist of any set of real numbers, regardless of how you translate the function right or left. And also, it doesn't affect the range because we're not moving the function up or down, we're just moving it right or left. So the range of real numbers remains the same. So the range remains the same. However, c directly affects the range, because if we shift this function up, the minimum shifts up. So the minimum that the y values can be, also moves up. Similarly, if we shift down, the minimum that the y values can take shifts down. So the value of c directly affects the range. That's all there is to translating functions. Simply remember that c denotes a vertical translation and d denotes a horizontal translation, and you'll be ready to tackle many types of problems. And that's all there is for Lesson 10, Horizontal and Vertical Translations of Functions. Stay tuned for next lesson, Lesson 11, Reflections of Functions. And if you like this lesson, be sure to give it a like and to subscribe, and also leave a comment down below. Thank you.